Welcome students, this is Professor P.P. Kulkarni. Today we are going to learn chapter number 5, Fundamentals of ENC System. In this chapter we will understand what is mean by a numerically controlled system, and the contents of the chapters are elements of ENC manufacturing system, concept of work zero and machine zero, then different types of ENC system we will learn, structure of ENC system, then different drives which are used in ENC system. Today we are going to learn also. Chapter number 5, Fundamentals of ENC. Welcome students. This is Professor P.P. Kulkarni. Today we are going to learn chapter number 5, Fundamentals of ENC System. In this chapter we will understand what is mean by a numerically controlled system, and the contents of the chapters are elements of ENC manufacturing system, concept of work zero and machine zero, then different types of ENC system we will learn, structure of ENC system, then different drives which are used in ENC system and their devices also, detailed steps in ENC manufacturing system, advantages of ENC manufacturing system, disadvantages of ENC manufacturing system, and then nowadays mostly used system that is called as a flexible manufacturing system. Elements of that flexible manufacturing system we will see, then application of FMS that we will see and at the last we will learn merits and demerits of flexible manufacturing system. So let us see one by one. First of all, understand what is ANSI system. A numerical control system is a system in which actions are controlled by direct insertion of numerical data at some point. This system must automatically interpret at least some portion of this data. In numerical control system, data is inserted and that data is in a form of numbers, letters and symbols. So we are going to learn part program in chapter number 8, and there we will see how these numbers, letters and symbols used in ENC systems. Today part programs can be generated directly by using CAD database ENC softwares. So for example, Delcam and Mastercams are softwares which are used for writing a part program or generating a part program automatically. Now let us see elements of ENC manufacturing system. There are three elements basically. First one is a program of instruction that is called as a part program. Second one is a machine control unit that controls the processes in manufacturing, and third one is the processing equipment, or you can call it as a tooling device. It performs all manufacturing operations. All these three elements, the first one is a part program, second one is a control machine control unit, and third one is a processing unit. All these three these are interconnected to each other, and by using these three elements we are going to manufacture a component in ENC system. Now let us understand what is a part program. A part program is a series of coded instructions which are required to produce a part. Now let us see here N10, G01, X 5.0, Y 2.5, F15. These letters, numbers and symbols are given. These are just one form for writing a part program. The coded instructions are composed of letters, numbers and symbols, and these are arranged in a sequence. Now let us see what is this N10. It is a sequence number. When you write a part program, N indicates line number of that part program. G01, it is a linear interpolation mode, but G is called G01, or G codes are called as a preparatory codes in part programming. Then X, Y, these are the coordinates. Also there is a Z coordinates that is used in the drilling operation. F indicates feed rate. It is shown here F15. So 15 is a value of feed rate and its unit is a inch per minute. Sometimes the units may change, it may be millimeter per minute. Now let us see, in part program there is a role of punched tape. So what is this punched tape? It is a medium to write a part program in NC system. Its length is approximately 1 inch. NC machine system coding uses alphabet characters, numericals and other special symbols in part program, and this part program is coded on a punch tape. So whenever you write a part program for NC system, you need a punch tape. So this punch tape uses a punch card. Its a picture is shown in this figure. This is the punch card, you can see here. Then there are some pictures of punch tape. There are different types of punch tape. There are also advanced punch tape that you can see. This diagram shows punch tape reader. It is just like old days we were using tape recorders. These are the rollers, and over these rollers punch tape is mounted, and when these rollers rolls, then punch tape is read by a machine control unit, and accordingly it performs the operations. So in this photo, FANUC it is shown, FANUC. This FANUC is a name of a controller, and this right one and the left one both are the rollers over which punch tape is mounted. Therefore it is called as a punch tape reader. Now let us see a very important control unit that is called as a machine control unit in NC manufacturing system. So machine control unit is a heart of numerical control system. What is its function? It reads coded instructions one by one in a sequence. It decode coded instructions. It provide decoded information to control loops of the machine axis of a motion. It also control machine tool operations, and there are some advanced tape which are used to repeat a punched tape again and again, so that part program will be repeated again and again. Also there are some codes used in part program to repeat a part program whenever you manufacture a component. Let us see the next slide. Machine control unit, it has basically two components. First one is a data processing unit, and second one is a control group unit. So DPU, what is its function? Data processing units, it reads a program, it decodes it, and it processes the information and it passes to CLU. Once again I read, data processing unit, it reads a part program, it decodes the part program, means it releases instructions given in the part program, then it processes the information which is given in part program, then it passes the information to CLU. Now what is this CLU? CLU is a control loop unit. It converts the information to control signals. CLU, it converts the information to control signals, and it drives the mechanism which receives a feedback about position and velocity of the tool, and it instructs data processing unit to read new instructions. Means CLU works for implementing all the instructions given by DPU. Once again I repeat, CLU works for implementing all the instructions given by DPU. At the last, CLU, it instructs DPU to read the new instructions which is coded in a part program. So both are very important in machine control unit. Now let us see the next bit of this chapter. It is a concept of work 0 and machine 0. Both are very important to write a part program in the machine. So this is a diagram of a lathe machine. Here you can see this diagram. Work 0 it is shown and machine 0 it is shown here. Now let us understand what is the work 0 and machine 0. I have shown this diagram by zooming it to just understand what is the location of work 0 and what is location of machine 0. Now you see here machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0 it is not a fixed point. You can see this diagram. Machine 0 is not a fixed point. It is shown at a location here, but it may be at another location in a machine. So it is not a fixed point. But if you see a work 0 normally sets at a front face and at the center of a job. So you can see this diagram. Work 0 it is normally set at front face and center of the workpiece. So while writing a part program, we take offset in a machine, in a CNC machine we take offset, and this offset is taken with respect to a work 0 and we write a part program. So once again I repeat, what is a machine 0? Machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0 it is not a fixed point, it is a floating point and it may be at any place in a machine. And work 0 it is normally set at front face and at center of the job. So work 0 is important to write a part program. Sometimes in examination we are asked to write a part program, but their work 0 is not defined, so we have to assume this work 0. So work 0 you can take at the front face at the center of the job, or you can take at any space on the work. So work 0 you must assume on the surface of workpiece itself. So work 0 is important to write a part program. It is a reference positions to define a coordinate in a part program. Now let us see types of ENC system, that is a classification of ENC system. First one is it is based on a motion type, point to point ENC system, then straight cut ENC system, then contouring ENC system. Next is the based on positioning system, incremental ENC system, absolute ENC system. Then on the basis of control system, open loop control system and closed loop control system. And next one depends on power supply, electric power supply, hydraulic power supply or pneumatic power supply. So let us understand these types of ENC system one by one. So first one is a point to point ENC system, PTP. So in this point to point ENC system, so coordinates or workpiece moves from one point to another point in a linear motion. You can see this diagram. So these points indicates motion direction of workpiece. Each point has coordinates and tool moves from one point to another point to third to fourth to fifth. So these points are nothing but you can call it as a holes which are obtained by using a drilling tool, and this drilling tool drills the workpiece is mounted on the table. So tool moves from point to point. So whenever you go for the drilling operation, you need a point to point ENC system, point to point ENC system. One example I will tell you: convex drilling. Convex drilling, it needs a point to point ENC system. Now let us see a straight cut ENC system. Straight cut ENC system is mostly used for milling operations. You can see this figure. In this figure, this is a milling tool, and there is a workpiece which is to be milled, and this spindle moves along the surface of the workpiece, and you can mill the component. So you can see here the direction of milling tool, in which it moves, that is shown in this diagram. So this tool moves from this location to this location in a direction of C section. So milling operation will happen from straight cut ENC system because tool is going to move in a straight direction along the surface of workpiece. Now let us see a contouring system. A contouring system, it is a very useful system. As per the desired path, as per the will of a manufacturer or a user, you can move the tool in any direction. Suppose I want to move the tool in straight direction, you can move. You want to move the tool in a circular direction, you can move. If you want to move the tool from point to point also, you can move. So desired cutter path that you can obtain by using a contouring system. A special contour you have to define for milling or a drilling operation. So contour system is used for both. Here in the diagram I have shown here, only a milling operation is shown in this diagram, but it can be also used for a drilling operation or a slotting operation. For both operation, if you want to create a slot in a particular contour direction or in a desired path, you can use this contouring system option. Now let us see the next type, incremental and absolute positioning system. So both are very important for writing a part program. Mostly we write a part program in absolute positioning system. So what is the difference in between these two, absolute system and incremental system? Let us understand this. So here one table I have shown here. In the table there is a absolute system coordinates and there are incremental system. These are the increment system coordinates and these are the absolute system coordinates, and these are the whole positions A, B, C which are shown in this diagram. This is the position of A, this is position of B, and this is position of C. Now what happens actually in the absolute coordinate system? Suppose this is a origin I have shown here. With respect to origin, coordinates of point A is written. With respect to origin, coordinates of point B is written. Similarly, with respect to origin, coordinates of point C are written. This happens in absolute coordinate system. But in incremental coordinate system, if you write a coordinates of point A with respect to origin, but while writing coordinates of point B, you should write the coordinates of point B with respect to point A. Means next point, while writing coordinates of next point, previous point should be a origin. Suppose in this diagram you want to write coordinates of point C, point B should be a origin. So previous point becomes origin and you can write the coordinates of next point. This is called as a incremental coordinate system. Both coordinate system mostly used for drilling operations only. You can see the difference exactly. In incremental coordinate system, x coordinate, y coordinates are written with respect to by assuming previous point as a origin. Now let us see absolute coordinate system. What are the advantages of absolute coordinate system? ACS. It is a very easy to check and correct a program written. If there is any mistake in a particular block means it is a line in a part program. Line in a part program is called as a block. If there is a mistake in a particular block, it will affect only the incorrect dimension mentioned in that block. It means if you have written any wrong instruction in a part program, only that line will be affected. Complete part program will not be affected. The other part programs remains unaffected as all dimensions are referred with respect to only one origin. So for getting an accuracy in the part program, we should consider origin for writing each dimension. We should consider origin for writing each dimension. Fewer efforts are required while transforming actual component drawing to NC component drawing. Then let us see what is the advantage of incremental coordinate system. For complicated components like pockets and races, the dimensioning system is more advantageous. And what is the disadvantages? Positioning errors are compounded in incremental positioning system. If position error occurs, all subsequent points contains the accumulated error. What happens? We see this diagram once again. If there is a error in positioning tool at point B, definitely there will be a error in positioning a tool at point C. So if tool position becomes wrong, next point will be positioned wrongly. If tool position is wrongly positioned, then next point will become wrong. So incremental coordinate system, rather I will say, it is quite risky to write a part program in incremental coordinate system. So better way, we will write a part program by using absolute coordinate system. For that purpose, G9090 is code is used, which is a preparatory code that we are going to learn in chapter number 8. Now let us see a next type of NC system on the basis of loop or control system, that is called as open loop control system. This is open loop control system. Now in open loop control system, there are the components. First one is a tape reader, second is a machine control unit, stepper motor, gearbox, lead screw and work table. Now already we have seen the components of NC system which consist of a tape reader, which consists of machine control unit, which consists of stepper motor, a gearbox, work table, but there is no feedback system. Tape reader reads the instructions given on a punched tape, that is followed by machine control unit which controls the instruction, which reads the instructions given in a tape reader, and it controls the motion of stepper motor. Stepper motor controls the motion of gearbox, gearbox controls the motion of lead screw, and lead screw controls the horizontal motion of work table. But in open loop system, as per the given instruction, if work table is not moving as per the instruction, there is no feedback system or there is no signal system. This is the error happens. So there should be always calibration of output of these systems. In open loop systems, that does not happen. Work table does not give feedback to the machine control unit, so that machine control unit can improve the controls over the stepper motor, it can improve the control over gearbox. So that lacuna is covered by a closed loop system that we can see here. Closed loop system, let us understand first of all, then we will see the advantages and disadvantages of each system. In closed loop system, there is a tape reader. You can see there is a tape reader in closed loop system. Once again, there is a comparator, which is a new component incorporated in closed loop system. Amplifier and signal processing unit, stepper motor, gearbox, machine tool movement. Now here you can see directly a machine tool movement, it gives a feedback to a comparator. Now what comparator does? comparator compares the actual machine tool movement and given machine tool movement in a tape reader. If there is a little bit difference in actual motion and given motion, then it simplifies and once again a comparator passes the instruction to amplifier and signal processing unit. Once again stepper motor is rotated and it controls the gearbox motion, and once again machine tool movement is controlled. Is for example, machine tool movement is programmed as a 5 mm in a part program, but in actual there is a machine tool movement of 4.9 mm, so there is a error of 0.1 mm. So comparator compares this 5 mm and 4.9 mm, so there is a error of 0.1 mm. So comparator once again gives instruction to the amplifier and signal processing unit. It moves the stepper motor, it moves the gearbox, it rotates the gearbox, it operates the gearbox, and so that there will be a movement of machine tool by 0.1 mm. So remaining movement of 0.1 mm will happen by the instruction of only and only comparator. So comparator is a new component which is incorporated in closed loop system. Now let us see advantages and disadvantages of both the systems. First one is these are less costly. Open loop system is less costly. These are less complex. These are easier to maintain and popular with smaller NC machines. Disadvantage is that there is no way to correct any error that may occur during operations because there is no feedback to controller. Just now I have discussed, if there is error of 0.1 mm, there is no chance to correct that error. Typically a lower torque motor is used in open loop closed system. Now let us see the advantages and disadvantages of closed loop system. Higher accuracy is achieved because of implementation of a comparator. Comparator is mounted in between tape reader and signal processing unit, as we have discussed. There is automatic compensation for error. As I told you, 0.1 error, 0.1 mm error is there, then it is compensated automatically. It is more preferred in large ANC machines because of the higher load. Disadvantage is that the systems are more complex and more expensive to buy and maintain. Now remaining part of this chapter we will see in a next video. All students are requested to watch the video and go through the test that I have uploaded on Google Classroom. Thank you very much for listening this lecture. You are requested to write your doubts in a Google Classroom. Thank you. Have a nice day. Welcome back students. This is Professor P.P. Kulkarni. In the last lecture we have seen types of VNC system. It was part 1 of the chapter 5. Now let us focus on the chapter 5 part 2. Here first of all we will see different drives systems which are incorporated in NC manufacturing system. First one is a stepper motor. A stepper motor, it is a basically electromagnetic rotary device which converts digital pulses into a mechanical rotary motion. Now you can see this diagram over here. There are some features of stepper motor. First one is a user interface, then indexer, then driver, and then motor. So user interface, it is used to write a program. It may be a PLC program, it may be a programmable logical control. Through the user interface, high level commands are sent to indexer. Indexer, it is simply a microprocessor which is capable of generating step impulses. Step impulses are nothing but test signals. These signals are given to a driver. So driver is used to convert the indexer command signals into a power which is necessary to energize a motor winding. And then at the last step motor, it is used to convert digital pulses into a mechanical shaft rotation. So this is a schematic of indexer motor which schematic of a stepper motor which explains the function of stepper motor. Next advantage of stepper motor that we will see, simple and cost effective design. This is the first advantage. It can work in open loop system, thus there is a no feedback system required. Excellent holding torque which eliminated brakes and clutches. Excellent torque at low speeds, you can achieve a good torque at low speeds. Maintenance free as it does not have brushes. High torque at low speed and a simple rugged construction that operates almost any environment. Now disadvantage of stepper motor, rough performance at low speeds unless you use a micro stepping. It consumes current regardless of load. If there is a no load or there is no even relation of load and current consumption, if there is no load, it also consumes a current. Limited sizes available for stepper motor and it is a quite noisy also. Torque decreases with a speed. This is one disadvantage. Then next, effective motor which is used in NC manufacturing system. Nowadays it is preferred mostly, that is called as a servo motor. A servo motor is a DC, AC or brushless DC motor combined with position sensing device. Once again I am repeating, a servo motor is a DC, AC or brushless DC motor combined with position sensing device. Servos are constructed for three basic components. These are constructed from three basic components. First one is a motor, then feedback device and control board. Now advantage of servo motors, let us see. High intermittent torque. High intermittent torque means what? Whenever there is no continuous flow of work, there may be a gap in between two works, so there will be a disturbance or interruption in the work. So torques are applied in different stages, that is called as a intermittent torque. Means intermittent means irregular torque. Then next advantage, it works well for velocity control. There is a high torque to inertia ratio. It is available in all required sizes. High speeds it can achieve and it is not noisy like a stepper motor. Disadvantage of servo motor is it is more expensive than stepper motor. It cannot work open loop feedback is required. So it cannot work with the open loop NC system because feedback is required in servo motor. It require turning of control loop parameters, it require tuning of control loop parameters, because there is always a signal from comparator to the machining device. So this, because of this feedback system, you need to tune all control loop parameters. In the last lecture we have discussed closed loop NC system. Closed loop NC system, it mostly uses servo motors, and these are tuned by using a comparator device. More maintenance due to brushes on brushed DC motors. So maintenance is obviously required for servo motors because of uses of brushes. Now let us see the next bit of this chapter, that is steps in NC manufacturing system. Their advantages, disadvantages. So basically there are 5 steps in NC manufacturing system. First one is process planning and scheduling. Second one is part programming. Third one is tape preparation. Fourth one is tape verification. Fifth one is production. Now let us understand these all steps one by one. In process planning and scheduling, it consists of NC drawings. Numerically controlled machine requires drawings of components. It requires machine data and availability of that data, availability of machine. Then it requires manufacturing data, data related to manufacturing such as parameter sets, feed rate, then different coordinates, speed which is required for manufacturing operations, electricity, etc. So lot of data is required in manufacturing, that is there in process planning and scheduling. It also requires develop sequence sheets. So in manufacturing operations there is a proper sequence of each operations, and that sheet is also required in the first stage. In the second stage we need a part program. A part program already we have learned, it may be a manual or it may be a computer assisted. You can write the part program manually, or you can generate that part program by using computers. A part program is a combination of letter symbols and numbers which is used to manufacture a component. Now third step in NC manufacturing system, it is a tape preparation. Now what is the tape preparation? It consists of machine language listing and transfer to a media. Now machine language listing, it consists of ATP processor, or it consists of coding devices for preparing tapes. Tape preparation means we are going to code a part program on different tapes. So for that purpose we need a machine language, different machine language which are used to code a part program on the tape. So it may require coding devices. Then transfer to a media. So whichever program we have written, it may be written on paper tape, it may be saved in a floppy, it may be mounted on magnetic cassettes, it may be there saved, it may be saved in hard disk, or it may be saved in MCU memory. So there are almost 5 devices available with us to prepare a tape and save that program on in the devices: a paper tape, floppy, magnetic cassettes, hard disk, and MCU memory. Fourth step, we have to verify the prepared tape. So for this verification we need a tool plots, we need a dry runs, or we need on screen simulation. If you have prepared a tape, on this tape you have written a part program, so you have to run that machine without doing a job, means that is called as a dry run. Just you are taking a checkup for your part program, and if you observe there is a problem in the movement of the tool, the movement of tool is not as per the program, then you have to go for corresponding changes in a part program. So once again you are jumping to step number 2 from step number 4. So in this way a prepared tape is verified by doing a dry runs. Nowadays different softwares are available, softwares like Delcam, softwares like Mastercam, which are used for on screen simulation. On the screen you can see how the job is manufactured, in what way tool movements are happening. All these things you can see on the screen. And last step is a production in the NC manufacturing system. Now in production stage you need NC machine operation tool, and NC machine operations tool, it requires setup sheets, NC sheets and work blank. So you need a ready machine tool with all gauging devices or inspection devices, all the tools which are necessary for manufacturing, coolants required for manufacturing. This consists of all the inventories required for production process. This is the step number 5. It also consists, one more thing I forgot to tell you, it also consists of tool presetting and compensation. So every now and then there is a movement of the tool, so there may be a change in the length of tool because of the operation, and there should be a compensation of the tool. If you change the tool in manufacturing operation, so reference in between tool point and the workpiece is changed, so that should be a compensated. So tool compensation is also considered in the production. So in the chapter number 8 we are going to learn different G codes for understanding compensation and tool presetting. So tool presetting is generally done with the help of digital vernier calipers, which are adjusted in horizontal and vertical levels. Now let us understand the advantages of NC system. Operator skill level requirements are reduced. This is one advantage. Non-productive time is also reduced. Non-productive time means time which is not utilized for actual manufacturing operation. Is, for example, tool is mounted, workpiece is mounted, but actual manufacturing operation is not started. That is called as a non-productive time. And when you remove the material from the workpiece, that time is called as a productive time. Greater accuracy and repeatability, low scrap rates, this is one advantage. Inspection requirements are reduced. More complex part geometries are possible with the help of NC manufacturing system, because you can go for a circular interpolation as well as clockwise circular interpolation and anti-clockwise circular interpolations. So complex geometry, in short we can say irregular shaped geometries you can manufacture by using NC system. You can go for contouring NC system for getting different irregular geometries. In the last lecture, one student from our class, Raju Padde, he has asked whether we can go for irregular geometries. So yes, my answer is that we can go for irregular geometries by using circular interpolation commands. Engineering changes are easy to make. So you need to change the part program, you need to change the feed rate, velocity, all these engineering parameters you can easily change in NC programming. Next is the simple fixtures are required in NC manufacturing, shorter lead times and reduced parts inventory and less floor space is required. These are the advantages of NC manufacturing system. Disadvantage, higher investment cost, because CNC machines or NC machines are more expensive. Higher maintenance efforts are required because these are technologically sophisticated. There is a tape preparation, there is a tape reader, even microprocessor size was also big in NC manufacturing system. So therefore higher maintenance efforts were required. Part programming issues are there. We need a skilled programmer. Even though we are going for an automation, we need a skilled programmer, a program which is helpful to do the manufacturing in less time. that is only done by a skilled programmer. So you need to write a part program which executes the manufacturing operation in less time. So we have to reduce a non-productive time, so we need a skilled programmer. So there is no option for that. Time investment for each new part is there. Repeat orders are easy because part program is already available. So you can, once you do the part program, you can go for the repeat of the operations. Higher utilization is required in ENC manufacturing system. Now next and last bit of the chapter that we will see a flexible manufacturing system and its components. So what is FMS? It is the most important system nowadays which is implemented in the industries. It consists of several flexible automated machine tools which are interlinked by an automatic material handling and movement system. So flexible manufacturing system, it must consist of automatic material handling and movement system. So there may be a use of material handling robots, or there may be a use of automatic guided vehicles for material handling. It can handle wide varieties of dissimilar parts. It is producing them in small numbers, even one at a time in a randomly. You can produce a part of different features, different sizes, having different traits randomly. So this system is a flexible. This system is able to respond quickly for any changes in required. So that comes under the flexible manufacturing system. If there is a change in the little bit operations of the manufacturing, there is a change in the size and shapes of the component, you can go for the flexible manufacturing system. The flexible manufacturing system, basically it has following components. First one is a workstation. Workstation consists of CNC machines. Then it consists of second part material handling. Material handling is done by using robots, transfer equipments, or ASR equipments, automatic robots or automatic guided vehicles. It consists of computer control, real-time control, and it controls different activities of the manufacturing system. Flexible manufacturing system, it may consist of direct numerical control DNC system. It may consist of computer numerical system. Applications of flexible manufacturing system, you can see here. Flexible manufacturing systems are typically used for mid-volume, mid-variety production. Means there is no more volume production or less volume production. Optimum volume, optimum variety of production. If the part of product is made in high quantity with the no style variation, then a transfer line or similar dedicated production system is the most appropriate. If the parts are low volume with the high variety, then numerical control or even manual methods would be more appropriate. Now let us understand this by using the figure here. It is shown x axis shows the production volume, y axis shows a product variety. In flexible manufacturing system, you can see production volume. Production volume is number of jobs manufactured during a production process. These are in medium quantity, and variety in these products is also medium. You can see it is a simple logic. If the production volume is low, there may be a product variety is a high, and if production volume is high, then product volume variety is less. So you can understand from this diagram. This diagram probably we have seen in chapter number 4 while learning the types of different automations: hard automation, soft automation, and flexible automations. So 3 types of automations, these are covered in this diagram. So flexible type of automation, that consists of medium product variety and medium production volume. In short, we can say optimum production volume and optimum product variety. Product variety means product has different features: size, shapes, functions, manufacturing operations, design operations. All these are different. That is called as a product variety. This is application of FMS. Now, what are the merits of flexible manufacturing system? Flexible manufacturing system can produce a large variety of the same type of products. This is also great advantage of FMS. Profit investment is there. The company invests a lot of capital in machines. However, FMS makes optimum use of these machines. Therefore, even though it is costly, FMS is a still profitable investment. So therefore, initially I told you, nowadays flexible manufacturing system is mostly used in almost all industry. It requires limited inventor. FMS required limited inventories compared to other production system, because FMS is a well planned manufacturing system. There is a less scrap rates, there is no chance of loss of material or storage of the material. Inventories are nothing but storage of the materials, raw materials. So these are required very less as compared to other production system. Low labor cost. In FMS, most of the work is done by the automated machines. As we have as I told you in the that chart, you need a computer or system, you need CNC machines, or you can go for the DN systems also. Also for material handling you need a robot. So therefore there is a low labor cost. There is a hardly any need of manual work or some human interference. Therefore in FMS labor cost becomes very low. Next is it is a flexible system. FMS is a very flexible. This is because it can produce a large variety of similar products. The quality and design of production can also be changed very quickly. Speedy production. The products can be produced very quickly because the materials are loaded, unloaded and transferred from machine to another machine by using robots. As a material handling is completely done by using automatic guided vehicles or robots. So therefore production process is done very quickly. So obviously production rate is higher. Now let us see the demerits of FMS. It is a very complex system. It is not easy to understand and it is very difficult to use it. This is one demerit. It requires highly skilled technicians because there are complex machines. Second one, it is also very difficult to repair these machines. Hence, employing or contracting a small group of highly skilled technicians to operate the maintain becomes mandatory. If you are going to operate your plant by using FMS, you need to take a contract for a small group of highly skilled technicians. So it is a mandatory because you need a skilled technicians for smooth flow of flexible manufacturing system. It needs high level of planning. FMS needs a high level of planning and more disciplined environment than other production system. Demands high initial investment. Obviously FMS needs high initial investment. As a result, only those businessmen or businesses that have huge capital can afford flexible manufacturing system and implement it. Almost in all automobile industries or different vendors of automobile industries, they use these flexible manufacturing systems. Small businesses cannot afford such a large investment and therefore they seek alternate system of production. So students, this is the end of chapter number 5. I am most thankful to you for listening this video. So you are requested to ask any doubt in a Google Classroom that we have created, or you are most welcome for any query.